In this video, we're going to take a look at three-number sum coding challenge. So what we need to implement is a function that accepts a nums array and has a target. What we need to calculate or generate is an array of arrays, and it contains elements which are also arrays, of course, and it has triplets inside them. If we look at an example, if we have target sum which is 10, a nums array, this is one example, so 2 plus 3 is 5 plus 5 is 10, right? So this is basically it, right? Let's put this pretty self-explanatory. Yeah, and let's talk about how we would solve this. So the brute force approach would be just to have 3 loops. So we would have like the first loop, the second loop, and the third loop, and we would just sum each index, right, when we're looping. And if the target sum is equal to current sum, we just append the current array to the results array, right? So this would be one way of solving this, but it would mean that runtime is cubed, and we could probably do better in terms of runtime, right? Another way of solving this would be to have a hash map and just store values inside it. So we could reduce runtime from cubed to squared of n squared. But then we would have problems with removing duplicates, right? So we would have 2, 3, 5, and then 3, 2, 5, and so on. So yeah, but we could also use a two-pointer approach, right? To solve this, we would just first sort an array, right? And then go from left to right. And because the array is sorted, the property between left and right pointer, so we have, let's say here it's the current I, right, pointer, and then left and right. If the array is sorted, when we sum up all the 3 numbers, if they match the target sum, we can just append the current pointer values, right? But if the target sum is not the same, what we can do is say, okay, cool, if the current sum is greater than the target sum, we can just move right pointer, right? Because the numbers are unique. If we move right pointer backwards, we will definitely make the current sum smaller, and vice versa. If the current sum is smaller than the target sum, moving left pointer forwards will make our current sum bigger, definitely, right? Okay, so let's look how this would turn out in code. Great. So let's have an array of 7, 1, 2, 3, 4, 5, 6. And the target will be 10, right? Let's first do brute force approach. Right? We need the results variable that holds up an array, and just have. Now we need to just implement 3 for loops, and we're done for I in range. And we stop at the, not at the end, for j in range. So we need to start j with an I plus 1, and yeah, this. And now we can have k, and k start with j plus 1, right? And then if I, j plus k is equal to target, we can append the current sum to a results variable. after we're done with looping, we can just return results. Okay, let's look at the results. So 7 plus 1 plus 2 is 10, and also 1 plus 3 is 4 plus 6 is 10. So this looks good. Cool. So this is one way of solving this. If we look at runtime, would be of n cubed. So this is for time, and for space, we could say that it's just a constant. So it's of 1. We're not allocating any additional space, right? But runtime is pretty bad, like cube time is pretty slow. And because we can make it a little faster, we can say, let's implement another function. Let's call it 3 sum 2. Cool. Let's call this solution using 2 pointers. First thing we need to do is, of course, sort an array. For this example, we will use built-in Python function. Just this function sorts an array in place, so this is good. After that, we need to loop over each element. For I in range len I, do -2. And then on each stage, we need to create our left pointer, which starts with y plus 1, and right pointer, which is just the last index, so length I minus 1. Oops. Cool. And then we need to have a while loop, while left is less than right pointer. We need to just calculate the sum, right? And the sum will be I plus left pointer value and the right pointer's value, right? And if the sum is equal to target, we can append of course, we need to have our results array. And because we know that our array holds only unique values, once we find the target sum, we can move both left and right pointers, right? Else if target sum is less than current sum, right? We need to make the current sum bigger, right? We need to make the current sum bigger, so we move left pointer forward, right? Else we need to make the current sum smaller, and we do this by moving right pointer by 1. Cool. Yeah, and after that, we just return results. So let's quickly look at the code. So first thing we need to do is sort our array. We store our intermediate values into results array. We have our first loop, which is I. We create our left and right pointers, and we hit then a while loop, which just calculates the current sum and compares it to target sum. Okay, it looks good. Let's run the code. So we see that our output for the second function is the same as the first. That's good. 1 plus 2 plus 7 is 10. Cool. So let's talk about time space complexity for this one. So for time, it's reduced. So it's O of n squared, right? We also have O of n log n, but because O of n squared is bigger, we can use just this one. This is for time. And for space, it's just of 1. It's actually space is bound to our sort function, so it depends what kind of sorting function we use under the hood. Either it's quick sort or merge sort, so it's bound to this guy. But the rest, it's basically all for 1 because we use 2 pointers. Okay, so I hope you learned something, and I hope you guys tune in next time. Bye.